Good evening and welcome to TL Physics, and today I'm going to talk about the photon. So the photon is a word used by Albert Einstein to describe a wave acting as a packet of energy. So one photon has this much energy. And the way to calculate this energy is using this formula here. That the energy that a photon has is determined by its frequency times by h. And this h is known as Planck's constant, which in your data sheet is 6.63 times 10 to the minus 34. Just double checking, 6.63 times 10 to the minus 34 joule seconds. You can also, since we know that the speed of light equals frequency times the wavelength, so the frequency is the speed of light over the wavelength, we could put that into this formula too. And what this tells us here is that the photons that have a really large wavelength do not have much energy, while those who have a really short wavelength have lots of energy. This is the whole idea of radio and gamma waves, that gamma waves have a very, very small wavelength, so have a lot of energy. That's why gamma radiation is deemed dangerous. But radio waves have such a long wavelength that each photon doesn't carry much energy at all. To give you an example, let's look at light. So red is approximately 700 nanometers and blue is approximately 400 nanometers. I may be slightly off, but they're the best ones I can do here. So the photon, the energy of a red photon would be C over lambda times by this Planck's constant, so 3 times 10 to the 8 over 700 times 10 to the minus 9 times by 6.63 times 10 to the minus 34. And that is 3 times 10 to the 8 divided by 700 times 10 to the minus 9 times by 6.63 times 10 to the minus 34, and that is 2.84 times 10 to the minus 19 joules. If I look at the energy of the blue, so I'm going to use this formula again. So I have 3 times 10 to the 8 over 400 times 10 to the minus 9 times by 6.63 times 10 to the minus 34. So 3 times 10 to the 8. 3 times 10 to the 8 divided by 400 times 10 to the minus 9 times by 6.63 times 10 to the minus 34. And I get energy of 4.97 times 10 to the minus 19 joules. So as you can see, blue light has a blue photon will have much more energy than a red photon. And this actually is useful to know. This is why red LEDs are far more common than blue LEDs. To be able to emit a red photon, the amount of energy that needs to be released is much lower than that of a blue photon. So to have a naturally blue LED would be much more harder, or would require much more energy from the circuit to produce than a red. And that is about a photon.